Okay, today I'm going to be talking about how GPS works. Right before I go into this, I just want to point out and for you to take note that when one talks about like how, oh, hey, let me get my GPS or your phone or car's GPS, that's actually not a GPS, it's a GPS receiver, in which it receives signals from a GPS, in which I'm just about to go in on what exactly is a GPS. Okay. GPS stands for Global Positioning Systems. It is 29 Earth orbiting satellites in which you need 24 for global coverage. Why do you ask? You need 24 for global coverage because you need 5 leftover satellites for spares. So basically, if any of the 24 satellites breaks down, um, you have spares. Okay, so GPS is based off the math principle trilateration. Trilateration requires 3 satellites in order for you to find your location, in which you can see right here, it is just using cities. And yeah, I'll be going on how to actually use trilateration to find yourself. Okay, so say you are in the United States and you do not know where you are at. Okay, but then you have a friend that tells you, hey, you are 1,000 meters from Boise, Idaho. And so if you take a map, you can go to Boise, Idaho, and you know that you are 1,000 meters away from it. So you can be 1,000 meters just anywhere around it. So here, just anywhere. And so that draws out a circle because you could be anywhere, 360. Okay, so you would just take like a pen and maybe a string, and you would put it on Boise, Idaho, and you would draw a circle with a radius of 1,000 meters. Okay, so since you know that you are 1,000 meters from here, you have another friend that tells you you are 1,500 meters from Minneapolis, which is over here. Okay, so now you have 2 circles, and you can see that they intersect at right here between these 2 points. And so where they intersect, you can be anywhere on that line. And yeah. So now let's say that you have another third friend that tells you you are 900 meters from Tucson. So you would just do the same thing with a radius of 900 meters and draw another circle. So now that you see all 3 circles intersect at one point, and that is where you are at, Denver. Okay, so that's trilateration in 2D space. And now we'll be talking about trilateration in 3D space. Okay, so now we're going to be going into 3D space. Okay, so 3D space. Your GPS receiver or your phone or something just needs to know the distance it is from 3 satellites. Okay, so those 3 satellites send out signals traveling at the speed of light, 330 million meters per second. And in order to find the distance you are from them, um, there is a formula d equals vt, which is distance equals velocity times time. And so velocity would be um, the velocity would be obviously speed of light, 330 million meters per second, and the time in which that signal sends almanac and ephemeris, which are digital information that tells you the location or like where the orbits like happen around the globe for the GPS receiver to see, and they tell the time that it took for the signal to reach the GPS receiver. Okay, so once you get that, you just have the formula and you just plug it in and you get the distance. And from that distance, from you and the satellite, you just draw another circle, but in this case, it would be a sphere. All right, and so you would do that for 3 satellites, and I'll be showing you. So over here, they're just calculating it. All right, they got the first satellite, And now you just need the second one. And so here again, I'll pause it. They intersect in spheres though. So you see that these two spheres intersect. All right. And so now we need our third sphere, right? So let's just wait for it. Okay, so now you got your third sphere, and that third sphere intersects with all three of them. And so since it intersects, you make 2 points here and here, and you know that you are going to be on Earth, so you can cancel out this point right here and use the Earth as a reference. Okay, so yeah, and then here again they just explain that, and they explain how you can use the Earth as a reference. So in the beginning of the video, I was talking about how you need only 3 satellites for you to calculate location, but a fourth satellite is actually needed for it to be more precise and for you to know your altitude. Okay, so up here it says Hertz versus atomic clock. Okay, so your GPS receiver has a clock in it, which is a Hertz clock. It's just an ordinary clock, while the satellite up in space has an atomic clock, a really expensive $50,000 to $100,000 clock, which can calculate down to a level of accuracy of nanoseconds, which is really, really low and precise at timing. Okay, so in space, you have that signal, right? And that signal from earlier that sends to the receiver takes time to get to the receiver, and so whatever you're reading, it's say like you're moving. That signal going to your receiver is actually going to be late, and so just by you or just by it being off, it'll actually your placement on the map or Earth would be maybe 100 or 1,000 meters off, and so that's not good or accurate at all. And in order for us to fix this, we have to set our clocks in sync, in which in space they have the atomic clock, right? Expensive clock, and then on our GPS receiver we have the Hertz clock. And so what we do in order to sync these two together, what we have to do is based off special relativity, the satellite is moving around, orbiting really quick. It's going through. It's going so fast that it goes through time so slow, based off special relativity, and so that would mean Earth would be going quicker, in which we would have to slow down our Hertz clock on Earth to match the atomic clock. Once the two are in sync, you will actually know your altitude, and it will be more accurate on your position on Earth. Okay, so yeah, basically that's all you need to know for GPS and the fourth satellite. The fourth satellite helps solve for accuracy and your altitude. And yeah, that's it for today. Thanks for watching, guys. I'll see you later.